You will analyze the graph and corresponding equation of a real-world parabola. You will choose an image, use Desmos to describe its characteristics using the vocabulary and strategies we have learned during this unit. Specific details are all in this Desmos activity. You do not need to worry about a Google Doc in Schoology. This is a major summative. This does count as a test grade. It is due April 9th, which is the last day of the quarter, but I encourage you to get it done sooner. Let's continue to the next screen to get started. The Eiffel Tower. Today we will be working with real-life objects and adding some quadratics to them. We will start by working together with the Eiffel Tower, and then you will get to pick one on your own to complete. Have fun, and remember your teacher is here to answer any questions. So here's an image of the Eiffel Tower, which is in Paris, France. So here's my picture of the Eiffel Tower that's on my Desmos graph. This is an equation of this orange line right here, okay? This is the equation of the orange line, quadratic that's right here, okay? There's the equation and there is the graph. So we're gonna label the points of this graph based on the vocabulary we've learned earlier. So the first word here is vertex. We're gonna type in the point below for the vertex, select label, and write the word vertex. So my vertex is the either maximum or minimum point, and it's the point where we change. This one goes increasing, 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 and then at some point it changes to be decreasing. So that point, if you actually click on the orange line, it'll highlight it for you. That is the point -4, 3. So I'm going to put in here -4, 3, okay? When you put in that point, this word label appears. So I'm going to check that box and I'm going to type the word vertex. That is the vertex of this quadratic graph, okay? We're going to continue and do that for all the different parts of this graph. So next it says x-intercepts and solutions. It says type in the points below for the solutions. Select the label and write the word solution for both. So my x-intercepts is where this orange graph touches my x-axis. So here, if you click on the orange line, it helps you out. Here's one of them, and here's the other one. Sometimes there's two, sometimes there's one, sometimes there's none. So my first one here said -7, 0, and you can make sure you type it in correctly because you see a purple dot will appear right there. I'm going to label this as a solution. That is one of my solutions. There's another spot here for a second solution. So if you click on the orange graph, that gray dot will appear, and that's at -1, 0. So I'm going to type in -1, 0. You'll see another purple dot will appear in that spot. And we're going to label this one as well. This is also a solution. Okay, so now we have our two solutions in our vertex. Okay, next is our y-intercept. Same thing, type in the point below for the y-intercept, select label, and write the word y-intercept. So here's my orange graph. Here's my y-axis right here. Okay, and I'm looking for where the orange graph touches the y-axis, and that would be right here. Okay, so that's 0, -2.333. I only require 2 decimals, so you can just put 0, -2.33. You'll see that blue point appears here. I'm going to label that as my y-intercept. Okay, so we've got all these points labeled on my graph. Next is the axis of symmetry. Okay, the axis of symmetry is a vertical line. So we're actually going to type x equals and then the number for the axis of symmetry. So your axis of symmetry is the line that goes through the vertex, okay? And it's going to be your x coordinate. So if I look at my vertex, the x coordinate is -4. So I'm going to type in here x equals -4. And it should always go right through your vertex there. Okay, but we don't want it to look exactly like my orange curve here. We want it to be a dashed line. So it says click on the settings button. And it says then the black circle and change it to a dashed line. Your circle's not black, yours is orange. You're going to click on that circle. And then notice here, this is the solid line it is. If you click here, it will become a dashed line. Okay. And now we just want to label it. We want to put the word. So I'm going to label this It says pick a point. You can pick a point anywhere. We just want to label this and right axis of symmetry, or AOS. So you're going to want to pick an x value of -4, because then it will be on this line. And there's not a lot of space up here, so I'm going to pick a y value down here. Let's say -5. So that way I can label this line and say it is the axis of, okay? And there we have all of our parts of our graph labeled: the vertex, the solutions, the y-intercept, and the axis of symmetry. All right, let's look at our next part. So now we're going to describe the characteristics of your graph from the previous slide. Remember, in Desmos, you have to type infinity for the infinity symbol to show up. So if you press this button, it will show your graph. The domain for all quadratic graphs is -infinity to +infinity. So I'm going to get my parentheses and type negative, and you can just copy and paste. Let's see. I want to type it, infinity. Oh, I guess you do have to type it, but the word is right there for you. Infinity, comma, +infinity. Okay, that is what we want to see, because on the right side and on the left side of this graph, it's going on forever. Okay, the range for this one, because it's pointing down, we're going to start with -infinity because it's pointing down, and it stops at the y value of 3. Because it stops at 3, I'm going to actually close it with a bracket instead of a parentheses. When you hit submit, the next part appears, end behavior. If we look at the ends of our graph, both of them are pointing down. This is a fancy way of saying on the left side of the graph. So it's saying on the left side, what's happening is it going down or up, and it's going down. This is a fancy way of saying on the right side of the graph. So on the right side of the graph, is it going down or up? It's going down. These two should always be the same for a quadratic. You're either both going down or they're both going up. Okay, does your graph have a maximum or a minimum? In this case, it is a maximum, okay, because it is a high point. We're going from increasing to decreasing. If it was a U, that would be a minimum. And your maximum is also your vertex, which is the point -4, 3. Okay, click submit. It says you have finished this slide. Make sure you check all your answers before moving on. All right, now we're going to factor our equation, and we will leave off the fraction. So we're only going to factor what is in parentheses from this in standard form. So I'm going to go ahead and circle this one here, and we're going to factor that. Remember, identify A, and A is actually 1 in there. There's a 1 next to x squared, B, and C. So I'm going to come over here to my x, and A times C goes in the top of my x. A times C is going to be 1 times 7. My A is 1, my C is 7. 7. My bottom one is my B, which is 8. So now I'm looking for two numbers who multiply to be 7 and add to be 8. So hopefully you can think about this off the top of your head. If not, you can always come over to Desmos, type in y equals 7 divided by x. Look at the table, and you will see that there's only 2 factors. Actually, there are 4. -1 times -7 gives you a +7, but 1 and 7, okay? And 7 plus 1 does give me 8. So those are going to be my 2 numbers here. Okay? So I'm going to use those 2 numbers over here. I'm going to keep my x squared the same from here. And I'm going to put my 1 plus 1x plus 7x, and then my plus 7 here. Okay? And now I'm going to factor it by grouping. Okay? I look at my first 2 terms here. Remember, there's a 1 here. 1 and 1 have a GCF of 1. If you need to check that, remember, you can always use your calculator. We can type in GCF of 1 and 1, and you get 1. We can divide these both by 1. They both have an x. So I'm going to write my 1x here, and then I'm going to divide. 1 divided by 1 is 1. x squared over x to the 1 you subtract, plus 1 divided by 1 is 1, and these x's will cancel because they're the same. I'm going to do the same thing for my other parentheses. I have a 7 and a 7. Again, if you need your Desmos. Okay. The GCF of 7 and 7 is 7. So I'm going to divide both of these by a 7. It's a positive 7, so plus 7 there. 7 divided by 7 is 1. Since there was no x with both of these, I didn't put an x with my 7, so that x comes down, plus 7 divided by 7 is 1. Okay, so now my final answer, I'm going to take these two, 1x plus 1. You can just write x plus 1. And my GCFs, 1x plus 7 is plus 7. Okay, and I'm going to write that into my factored form. Negative 1/3, that just kind of hangs out, x plus 1 and x plus 7. It doesn't matter the order. If you put the 1 here first and the 7 second, it doesn't matter. All right, let's move on to the next part here, which is our intercept form. You'll notice our intercept form is actually the same as right here, our factored form. Okay, they're the same thing. We're going to use the table below to identify A, P, and Q. So my A is negative 1/3. That's this one. Remember, your P is always opposite. So I see x plus 7. I'm going to put a negative 7. Q, I see x plus 1. So I'm going to put a negative 1. Okay. Then it says find the axis of symmetry. P plus Q divided by 2. So you can type it right in here. See how there's this divided by? I'm going to type that first. And then type in negative 7 plus negative 1 divided by 2. I get negative 4. I'm going to take that negative 4 and put it here. This is my axis of symmetry, okay, AOS. So I'm going to put negative 4 here. And then I'm going to substitute it in. Anytime I see an x, I'm going to put a negative 4. Negative 1/3, parentheses, negative 4 plus 7, negative 4 plus 1. If you hit tab or enter, it will tell you the answer is 3. So that's my y. My xy is negative 4, 3. And you can check that, okay? If we remember back to our first slide, I'll go back there in a second. My axis of symmetry was at negative 4, and my vertex was negative 4, 3. And remember, my solutions, my x-intercepts were negative 7 and 1. Let's go back and just see that. There's your vertex, negative 4, 3. Your axis of symmetry, negative 4. And my solutions, negative 7 and negative 1. So it all interacts. All of this stuff is connected. Okay, the last piece is on slide 7. Find the discriminant, then solutions using the quadratic formula. So first I'm going to label A, B, and C here. So my A is with x squared, that's 1. B is my 8, and C is my 7. It's the same A, B, and C from slide 5. And I'm going to find the discriminant. I have my B squared, which is 8 squared, minus 4. My A is 1, and my C is 7. All right, I can type that right into my calculator. Parentheses 8 squared minus 4 times A times C. And I get 36. That's your discriminant. So I'm going to fill that in the box here. Submit. And my number of solutions. I would have one real solution if this was 0, but it's not. I have 2 real because it's positive. 2 non-real would be if it was negative. All right, last piece of my project here is to fill in and find the solutions using the whole quadratic formula. So I'm going to write x equals, it says negative b. I'm going to do a different color actually. X equals negative, my b is 8, plus or minus the square root of 36. That's your discriminant. That's what we just found over here, all over 2 times my a value, which is 1, So now I can simplify. Negative 8 plus or minus the square root of 36. You want to type that in here, square root of 36. It's a perfect square. I get 6 all over 2 times 1 is 2. Now, because we were able to simplify that perfect square, we have to do 2 versions of this. So we're going to have to do negative 8 plus 6 over 2 and negative 8 minus 6 over 2. Okay, so I'm going to come over to my calculator. I'm going to click division first because, again, you have that fraction. I'm going to type in negative 8 plus 6 divided by 2, and I get negative 1. So that is one of my solutions, is negative 1. And then the other one I'm going to do, division, negative 8 minus 6 divided by 2, and that will give me negative 7. Okay, and these are my solutions. Again, if you go back to our graph, those are my solutions, negative 7 and negative 1. So it all interacts. The last thing you'll need to do with your project is do a written summary where you just need to do some research on your particular location. For this one, it was the Eiffel Tower. So just find some basic information about where it is, who constructed it, and anything else you find interesting about that location. Good luck.